The 3,000 horsepower boiler monster, the engine that turned factories into time bombs. In the annals of industrial history, few machines have evoked as much dread as the stationary steam boiler. A seemingly innocuous piece of equipment, it was the powerhouse behind the rapid expansion of American industry in the late 19th and early 20th centuries. However, its potential for catastrophe was often overlooked, leading to devastating consequences. The story of the 3,000 horsepower boiler is a tale of greed, negligence, and the tragic cost of prioritizing production over safety. This article delves deep into the dark legacy of these industrial giants, exploring the factors that led to catastrophic failures and the systemic issues that allowed them to persist. On a fateful day in March 1905, the gauge needle on a boiler climbed past 180, then 200, and finally locked at a number that would spell disaster. The operator, realizing the impending danger, lunged for the safety valve, but it wouldn't budge. In a matter of seconds, 3,000 horsepower of superheated steam tore through 6 inches of riveted iron, launching a 40-foot boiler through the brick wall like a cannonball. The explosion hurled men 150 feet into the air, and the building's third floor collapsed onto the machinery below, burying 23 workers beneath tons of twisted steel and scalding water. This was not an isolated incident. It was a grim reminder of the era's industrial negligence, where safety was often sacrificed at the altar of profit. The question that arises is not whether such explosions could have been prevented, but rather how many individuals recognized the dangers and chose silence over action. To understand the scale of this tragedy, we must first journey back to the industrial landscape of America in the late 1800s. Factories were the lifeblood of the economy, and the steam boiler was the heart that pumped energy into every machine. In 1880, the factory floor operated under one brutal truth: no steam, no money. Every loom, lathe, and stamping press was connected to a central power source, traditionally the water wheel. However, the post-Civil War industrial boom demanded a more reliable and powerful solution, leading to the adoption of stationary steam boilers. These massive machines, often 30 feet long and 8 feet wide, held thousands of gallons of water heated to 200 degrees under immense pressure. One boiler could power an entire textile mill, while multiple boilers could drive the heavy machinery of steel foundries and locomotive factories. The economic incentives were undeniable. Larger boilers meant more machines, more workers, and ultimately more profits. Yet, factory owners faced a critical decision: operate within safe limits or push beyond them to outpace competitors. Most chose the latter, connecting boilers in series, using cheaper coal, and delaying necessary maintenance. The pressure, both literal and financial, mounted, creating an environment ripe for disaster. As the boiler room became the epicenter of this industrial pressure cooker, the men who tended to these behemoths worked under grueling conditions. Shoveling coal into fireboxes that glowed white-hot, they endured 12-hour shifts in temperatures reaching 120 degrees. Their primary responsibility was not to ensure safety, but to keep the machines running at all costs. By 1890, over 100,000 stationary boilers operated in American factories, each capable of unleashing catastrophic energy. The unspoken rule was clear: production over caution, profit over safety, output over everything else. But the construction of these boilers was fraught with potential pitfalls. Thousands of hand-driven rivets held overlapping iron plates together, and any minor error in the riveting process could lead to catastrophic failure. A single misaligned rivet could create a weak point in the structure, allowing steam to escape and pressure to build dangerously. In 1854, a boiler explosion in Hartford, Connecticut, killed 21 workers due to defective rivet holes that allowed steam to escape. The company had accepted the boiler without independent inspection, highlighting a systemic failure in safety protocols. The corrosive nature of water also posed a threat. Operators often overlooked the importance of water chemistry, leading to scale buildup and corrosion that weakened the metal over time. Despite warnings from inspectors, many factory owners continued to operate dangerous boilers, prioritizing profits over safety. In 1893, a Massachusetts inspector reported finding hundreds of boilers in dangerous condition. yet many were returned to service with minimal repairs. The physical evidence of impending disaster was clear, yet it was often ignored until it was too late. The men operating these boilers were often untrained and lacked the knowledge necessary to recognize the signs of impending failure. They relied on instinct and experience rather than formal training, leading to dangerous miscalculations in judgment. In Braidwood, Illinois, in 1883, a boiler exploded, killing 69 miners. The operator had noticed the pressure gauge climbing but assumed it was a temporary spike, unaware that the safety valve had frozen shut. His lack of training and understanding of the system led to a catastrophic decision that cost lives. The pressure to maintain production was immense, and operators were often caught in a no-win situation. If they shut down for safety concerns, they risked their jobs. If they pressed on and an explosion occurred, they would be blamed for negligence. The average boiler operator earned meager wages, working 6 days a week, and faced pressure from foremen to keep production up, regardless of conditions. This culture of fear and ignorance created a perfect storm for disaster. Safety valves were designed as a safeguard against human error, yet they became the first line of tampering. Many factory owners modified or disabled these critical devices to increase pressure and output, often without understanding the dire consequences. Massachusetts law mandated safety valves calibrated to release pressure below maximum working levels, but many owners found ways to circumvent these regulations. The tragic explosion at the R.B. Grover Shoe Factory in Brockton, Massachusetts in 1905 serves as a stark example. 3 stationary boilers exploded simultaneously, killing 58 workers and injuring 117. Investigators found that the boilers had never received professional inspection and that safety valves were set to release at dangerously high pressures. The plant superintendent had been warned about bulging shells but chose to ignore the warnings, leading to a disaster that could have been prevented. The aftermath of such explosions was often gruesome. Superheated steam caused severe burns that penetrated deep into the skin, leading to agonizing injuries and high mortality rates among victims. Doctors of the era struggled to treat these injuries, and many survivors faced months of painful recovery. As the death toll from boiler explosions mounted, insurance companies began to take notice. The Hartford Steam Boiler Inspection and Insurance Company emerged as a key player in documenting and investigating these incidents. Their findings revealed a disturbing pattern. Preventable human decisions rather than mechanical failures were responsible for the majority of explosions. By the late 1890s, the statistics were alarming. An estimated 2,000 Americans died annually in boiler explosions, often without public awareness or outrage. Investigations revealed that factory owners routinely deferred maintenance and ignored safety protocols, prioritizing profits over worker safety. Public sentiment began to shift as labor unions and reform groups pushed for government intervention and regulation. In 1907, Massachusetts passed the first comprehensive boiler inspection law, requiring annual examinations and establishing minimum safety standards. However, the implementation of these laws was often inconsistent, and many factories continued to operate unsafe boilers. The introduction of electric motors in the early 20th century began to change the landscape of industrial power. Electric motors offered a safer, more efficient alternative to steam, leading to a gradual decline in the use of stationary boilers. By 1915, new factory constructions increasingly specified electrical systems, marking a significant turning point in industrial safety. And